All right. Now the main thing is that although some of you might have seen some kind of binary files for videos or audios, that does happen occasionally, but normally we do not interact with with a file that's directly dot bind like it's stored as dot dat binary files. So we normally don't interact with those kinds of files directly. The files that we interact with are more like mp3, mp4, jpeg. So those are different file types. Again, it's data storage only, so it's data representation, but it's a different kind of file type. So let's start with the first one that we have over here. It's musical instrument digital interface, so midi. What this is basically a communications protocol, and it allows different musical instruments to interact with each other. Now, it was initially created as a standard for different instruments to be able to converse with each other, because again, there's a lot of variety when it comes to music, especially. But for conveying the same basics, people preferred or actually wanted a communications protocol that could be standardized. So it's used for storage of these kind of music files. Now, although this doesn't contain any kind of actual notes, it does contain something called a status byte, and then it has data bytes. All right, we'll see an example of how an MIDI command actually looks like just in the next slide. But the idea is that it is a communications protocol. It is more of a set of instructions than anything else. Actually, it's essentially a set of demands, as you can see in the third point. It's stored as a series of demands. All right. Now the thing with it is it needs a lot of memory storage. Why? Over here, so you can see that. So you can understand that the note on message, it's a very simple message. All right, there's one note. And I understand there's a lot of complexity involved in music, and that's why it requires, you can see, 3 bytes for one single message. So this is a status byte, which is essentially, you can understand over here that it is the MIDI channel. All right, so it can range from 0 to 15, and then you have 2 data bytes. One conveys the pitch and one conveys the velocity. All right, and it's a very simple message, but it requires a comparatively lot of data. And you can imagine that this is one simple message compared to, say, you're trying to store an entire musical piece. So you can understand how much memory will be needed. All right, so that is why MIDI is more of a set of commands than anything else, and it requires extensive data storage. So, all right. Moving on, we have MP3. Now, MP3 is something is another form of audio storage, and this essentially, the main key factor of MP3 is that it reduces your file size significantly. Like, it's almost said to be 90%. All right, from any other kind of audio format. So it uses audio compression to convert your sounds into much shorter, like less data intensive formats. But the idea is that you will lose some kind of information, and that is why this form of compression is called lossy. We'll discuss different compression forms eventually, but the idea is that it is a very again efficient way of data storage, and it's very commonly used in, like, often by all of us. Hopefully you've all used mp3. So the idea is it's a data representation for audios. All right, mp4 and jpeg. Now mp4 is essentially, again, hopefully you've all seen this. It's basically storing music, videos, photos, animations. All of this can be stored. Now it can it doesn't really lose a lot of quality when you're storing it as mp4. So it's generally that's why it's a very popular format of storing data. Hopefully you get the idea. Then you have jpeg. It's a file format used to essentially reduce the size of photos. So what it does is it reduces the resolution of a picture. Now what this basically does is that it reduces the size of your picture by reducing the complexity in some ways, which is by reducing the number of pixels in a particular given area. All right, so essentially the more pixels you have, the more resolution you have. Hopefully you understand how that works, because it's like 1080 pixels, you can, that's the best resolution. Then 720 pixels is what's considered HD normally. So essentially by changing the picture resolution, you're reducing the number of pixels. And what you do that and what happens with that is, since you have to store less pixels, and that's how your data storage gets, more efficient, it gets reduced, but you also lose a lot of quality. So it depends, and it may convert the image, it may reduce it by a factor from 5 to 15, but it really depends, because the idea is to not lose so much quality while you're converting these, while you're compressing these images. So essentially the idea is to make sure that whatever compression takes place does not lose a lot of quality. So that's basically what JPEG is. It is a way to store pictures. Hopefully you got the general idea of data representation. It's quite simple. It's basically, we went over the different forms of data representation, which is binary, decimal, hexadecimal. We went over a couple of file formats. And for the last thing that we have right now is file compression. All right. So file compression is of essentially mainly two types. Lossy compression, which we just saw right now for MP3. What that means is that it will remove all the unnecessary bits of data. Like I didn't specifically read this out, but in MP3, it reduces sounds that humans just can't hear. All right, so there's some frequencies that humans biologically cannot hear. So it removes all those kinds of sounds. And once you've compressed a file using this particular way, you just cannot get the file back. All right, so that's why it's called lossy. And again, you can see a general comparison out here. And lossless compression is essentially, you can you don't actually lose any kind of data. All right, so what it does is it reconstructs the original file, but you do not lose the original file. So that's very important. All right, in certain cases, the thing is that you can't lose data in something like a spreadsheet. All right, because these are, every single piece of data has to be important. All right, so you can't simply just lose them. So what you do is you try to reconstruct the original file, but with, essentially less complexity, so that you don't have to take so much data. That's the general idea of lossless compression. You can just go over this particular table. Again, the general idea is that this lossy compression reduces the quality, because as we saw, MP3 gets rid of some things, and so does JPEG gets rid of the pixels. Then you have lossless compression, which does not reduce the quality. Data reduction is higher, data reduction is lower, again because it's lossless, so you're trying to preserve the data, preserve information, so you can't lose that much of data. That's the general idea. Again, because data reduction is higher, the resultant file is much smaller. The resultant file is probably not as small as it would be if it was a lossy compression. And again, this is used for text files or data files, which preferably you don't want to lose a lot of data from. So that's the general idea, and hopefully you got the storage and different kinds of data representation, file compression. And thanks a lot for listening. Thank you.